Dr.B.Krishnaveni, working as an assistant professor in Department of Mathematics, Aditya University. Today we are going to discuss about quadratic forms. In this, we will get an idea what is meant by quadratic form and how to write the matrix of the quadratic form as well as how to find the nature of the quadratic form. So, means at the end of this lecture, student will be able to write the matrix of the quadratic form and can find the nature of the quadratic forms. So first, let us move to the definition of quadratic form. So, what meant by quadratic form is a homogeneous expression of a second degree in any number of variables is called quadratic form. So, here it is very clear that you can see the words, it is a homogeneous expression and must be second degree in any number of variables. So that we call it as a quadratic form. So here you can see an example and can understand easily. So if you see this form containing three variables, those are x, y, z, and it is homogeneous. Since the power of every term is same, that is equal to 2, that means it is a homogeneous expression of second degree of three variables, that is x, y, z. So therefore we call it as a quadratic form in three variables. So now let's see how to find out the matrix of the quadratic form. Let us take the quadratic form takes the form ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy. So you can see this polynomial which is a quadratic form in three variables. What are they? X, Y, Z. So how to write the quadratic form for this is A is equal to coefficient of x square, coefficient of y square, coefficient of z square, representing diagonal elements. Remaining all are mixed coefficients, that is coefficient of xy, yz and zx. So now you can see, I can explain this easily how we can write the coefficients. So while writing the matrix of the quadratic form, first to see the quadratic form containing what variables is. So here the variables are x, y, z. So let us represent each row and each column of the matrix with x, y, z. So now do this x into x representing x square, means this term gives coefficient of x square. And what about this term is x into y, which is coefficient of xy, and this x into z, coefficient of xz. Thereafter, again here what you are getting, y into x, again we are getting coefficient of xy. So 2 times you are getting coefficient of xy, that's what we have divided the coefficient by 2. So next, what this term representing, y into y is a y square, which gives the coefficient of y square. And here y into z, coefficient of yz. And again here we are getting coefficient of yz, again 2 times we are getting, so that's what we calculated, 1 by 2 of that coefficient of yz. Next, similarly 1 by 2 coefficient of xz. Here xz and here again zx, that is xz. Finally this one is z into z is z square, coefficient of z square. Hope you have understood. So after getting the quadratic form in given variables, represent each row and each column with the given variables. So thereafter do the here first row representing x square, x into y xy, x into z xz. Second row y into x, that is xy, y into y is y square, y into z yz, z into x xz, z into y or yz, z into z z square. So if you do this, we are getting x square, y square, z square only once. We have taken directly coefficient of x square, coefficient of y square, coefficient of z square directly as the diagonal elements. For the mixed coefficients, we are getting 2 times xy, xz, yz. So now to write those coefficients, since occurred 2 times, so hence we divided the coefficient, each coefficient by 2. Xy coefficient by 2, xz coefficient by 2, similarly yz coefficient by 2. So finally, on taking this, what the coefficient of x square, coefficient of xy by 2, that is 2h by 2h, coefficient of xz by 2, 2g by 2, that is a g. Here again coefficient of xy by 2, h, coefficient of y square, b, coefficient of yz by 2, 2f by 2, that is f, coefficient of xz by 2, 2g by 2, g, coefficient of yz by 2, that is 2f by 2, which is f, and here it is coefficient of z square, that is equal to c. So let's take the question on this. Here the quadratic form given by 3x square plus a 5y square plus a 3z square minus a 2yz plus a 2zx minus 2x. And here it is very clear that it is a quadratic form in 3 variables which are x, y, z. So as it is, here I will explain with an taking an empty matrix. I am representing each row with x, y, z, each column with x, y, z. Thereafter I am writing the coefficients in the matrix. Here it is coefficient of x square. What is coefficient of x square is 3. Next is coefficient of xy. And once again here you are getting again coefficient of xy. So here we need to take coefficient of xy by 2. So what is xy coefficient is minus 2 divided by 2 is minus 1. And here is coefficient of xz and occurred 2 times again here. So hence we need to consider coefficient of xz by 2, 2 by 2, which is 1. Next, coefficient of xy, already calculated, divided by 2, that is minus 1. Coefficient of y square. What is coefficient of y square is 5. Coefficient of yz divided by 2, minus 2 by 2, minus 1. Coefficient of xz by 2, xz coefficient is 2, 2 by 2 is 1. Coefficient of yz by 2, yz coefficient is minus 2, by 2 is minus 1. Finally, coefficient of z square, coefficient of z square is 3. So if you do follow this, you can easily write the matrix of the given quadratic form. So in the previous, we go through the quadratic form and wrote what is its matrix. If matrix is given, then how to write its corresponding quadratic form? That is the next question is. So need to express the matrix into the quadratic form. So depends upon the order of the matrix, we need to fix the number of variables. So you can see this example. Here it is 3 variables. That's what we got, a matrix of order 3. If it is 4 variables means we will get a matrix of order 4 and so on. Depends upon the order. We can easily tell what is the number of variables for the given quadratic form is. If you see this matrix, it is of order 3. So hence, we can say that the quadratic form contains 3 variables. And what is the matrix form of quadratic form is? We can write the matrix from the quadratic form as x transpose ax. X is a variable matrix. This transpose is x transpose. And A is the coefficients. Now by using this, we can find out what is our quadratic form for the given matrix. So let us take x, y, z be the 3 variables of the given quadratic form, and we know that quadratic form is given by x transpose ax. Since we have taken x is equal to x, y, z, its transpose is row x, y, z. The matrix 0, 1, 1, 1, 0, minus 1, 1, minus 1, 0, and x, that is column x, y, z. So now multiply the first 2 matrices, then results row y plus z, x minus z, x minus y, then multiply with column xyz. Finally, we are getting the form as xy plus xz plus xy minus yz plus xz minus yz, which is equal to 2xy plus 2xz minus 2yz, which representing the quadratic form in 3 variables. Here, I need to say one note at this point. Quadratic form. Quadratic form is a homogeneous expression of a second degree in any number of variables. And a quadratic form can be written as the matrix form as x transpose ax. Here we call A is a symmetric matrix. A is nothing but symmetric matrix. So now how to decide or what is meant by nature of the quadratic form. So the nature, either it may be positive or negative or any else, how to get that nature of the given quadratic form is. So here we can see that a real quadratic form x transpose ax is said to be positive definite. When we say that it is positive definite if all the eigenvalues of the matrix of quadratic form are positive. Okay. So that means if all the eigenvalues of the matrix of the quadratic form are positive, then we say that the quadratic form is positive definite. And it is called negative definite when all the eigenvalues of the matrix of the quadratic form are negative. So positive definite means all the eigenvalues of the matrix of the quadratic form must be positive. And if all the eigenvalues of the matrix of the quadratic form are negative, then we say that it is negative definite. Now come to the next one, and we call, or we said that it is positive definite when all the eigenvalues of the quadratic form are positive, that is greater than or equal to 0, and at least one eigenvalue is equal to 0. So one more condition it has to satisfy to say that the quadratic form is positive semi-definite. What that is? All the eigenvalues must be positive, and in addition to that, at least one eigenvalue must be equal to 0. Then we say that the quadratic form is positive semi-definite. Next is negative semi-definite. When we say that it is negative semi-definite, when all the eigenvalues of the matrix are less than or equal to 0, that means a negative, and at least one eigenvalue must be equal to 0. If all values are negative and at least 0 means we say that it is negative semi-definite. There are the case that we will get eigenvalues both positive and negative also. In that case, what we say that quadratic form is, we call it as indefinite. Means if we call the quadratic form as indefinite if some of the eigenvalues of A are positive and the others are negative. In this way, we can decide what is the nature of the given quadratic form. I repeat, it is called positive definite if all the eigenvalues of the quadratic form are positive. It is called negative definite when all the eigenvalues of the quadratic form are negative. Positive definite if all the eigenvalues of a matrix of the quadratic form are positive and at least one is equal to 0. Negative semi-definite if all the eigenvalues of the matrix of quadratic form are negative and at least one eigenvalue is 0. Finally, we call it as indefinite if both, that means some of the eigenvalues are positive, the others are negative. Next, we will decide what is the rank of the quadratic form. How to find that? You can see here the number of non-zero eigenvalues. That number gives the rank of the quadratic form. Next is index. The number of positive eigenvalues of the matrix A is called index of quadratic form. So after calculating eigenvalues, we can decide all this. Rank is nothing but number of non-zero eigenvalues of the matrix A. Index is number of positive eigenvalues of the matrix A. Then what is signature of quadratic form is? It is the difference between positive and negative eigenvalues of the matrix A of the quadratic form. We call that as signature of the quadratic. So now we will understand how to find out the nature of the quadratic form. So the question is finding index and signature of the quadratic form. X1 square plus 2x2 square minus 3x this. So it is very clear that it is representing a quadratic form in three variables x1, x2, x3 and getting the components only for x1 square, x2 square and x3 square. There are no mixed terms in this quadratic form, which means we are getting only diagonal elements, that is coefficient of x1 square, coefficient of x2 square, coefficient of x3 square. Remaining coefficients, coefficient of x1, x2, coefficient of x1, x3 and so on are all equal to zeros. So that's what we got a diagonal matrix for this given quadratic form. So now in order to get a nature as well as index and a signature of the quadratic form, first of all we need to find out eigenvalues. And we can use here one of the property of eigenvalues. What kind of matrix it is? Diagonal matrix. So then there is no need to find out characteristic equation, thereafter solving that equation, then finding the roots of that equation which use eigenvalues. Since it is a diagonal matrix, we can use the property. The property is the eigenvalues of the diagonal matrix are diagonal elements. So hence directly we will take the diagonal elements as the eigenvalue by using the properties. So therefore, what are the eigenvalues for this matrix of the quadratic form are 1, 2, minus 3. So now we'll see one by one. So first they ask the question about index. Index is number of positive eigenvalues. So out of 1, 2, minus 3, how many positive eigenvalues are there? 2. So therefore index is equal to 2. Next is asking signature. Signature means difference between positive eigenvalues and negative eigenvalues. Here how many positive eigenvalues? 2 positive eigenvalues minus number of negative eigenvalues. Only one, that is a 1. So therefore 2 minus 1 is equal to 1, which gives the signature. So now for this, if you want to find the nature also, didn't ask in the question, but if you ask it the nature, we got the eigenvalues are 1, 2, minus 3. So means it consists both the positive as well as negative eigenvalue. So means we call this as indefinite. What is the nature of this quadratic form is indefinite because it contains both the positive and a negative eigenvalues. This is another question. The question is finding the nature of the quadratic form x1 square plus 5x2 square plus x3 square plus 2x1 x2 plus 2x2 x3 plus 6x3 x1. It is very clear that again we have three variables in this quadratic form. Those are x1, x2, x3. First write down the matrix of the given quadratic form. Coefficient of x1 square, x half of the quotient of x1, x2, 2 by 1, 2 by 2, 1. Coefficient of the coefficient of x1, x3, 6 by 2, that is equal to 3. Next, coefficient of x1, x2 by 2, that is a 1. Coefficient of x2 square, 5. Coefficient of x2, x3 by 2, 2 by 1, again equal to 1. Coefficient of x3, x1 by 2, 3. Coefficient of x3, x2, 2 by 2, 1. And coefficient of x3 square, 1. Now for this, we need to find out eigenvalues, find the characteristic equation, and then find the roots of this equation. We got for this, the eigenvalues are minus 2, 3, 6. So now, in order to decide the nature, again it contains positive eigenvalues as well one negative eigenvalue. So therefore here we are getting some eigenvalues are positive, the others are negative. Therefore the nature of the quadratic form is indefinite. So hence in this lecture what we have discussed is how to write the matrix of the quadratic form and how to state the rank, index, signature and nature of the quadratic. Thank you.